Right, normal distribution. So just want quickly, if you want to turn to this page 87 in a textbook, so you might need to go and get a textbook. Right, page 87 in the textbook. Pause the video while you're all getting books. So following on from talking about that dispersion, just a quick one. You're going to have to do lots of work on normal distribution in the future and really understand it, but I'm just introducing it to you now. So we've done standard deviation as a measure of spread. We have talked about what a normal distribution means. Any idea? Can you remember?
Isn't this a normal?
Yeah, it's on the screen in front of you, that kind of shape. But what does it mean? What do you think the word normal means?
It has like a peak, like
Lots of distributions will have a peak, actually.
It like, it's it starts off like slow, and then gets higher. Slow.
True, it does. I mean, you're describing what's on the screen, yeah?
The data is like evenly spread, so it will go like...
It's not evenly spread as such, but I get what you mean. There's a symmetry about the curve.
Yes.
I'm actually not asking you to describe the shape. I'm asking you to explain what do you think the word normal distribution would be.
It's like even on both sides of the mean.
Yeah, again, you're describing the shape, but what do you think the words normal and distribution, why are they linked together? Samuel? It's really easy, actually. It's not very mathematical. It's not even, is it? You can see there's a peak, and I mean, it is symmetrical. Go on then. Okay, great.
There are no outliers?
Well, there aren't. But again, what do you think? The word normal. Come on.
It's not...
It makes sense.
There's no definition for normal.
There is normal. You guys are
Regular.
not normal.
Oh.
It makes sense. It makes sense that it goes like that. It's normal because it makes sense.
Let me put it in this sense, right? You guys, I kind of explained to you, you guys would be on one particular part of this curve. You would be at the top end. You are, because of your privileged situation, you know, and the excellent education you get, you would be at one of the top ends in terms of educational achievement. Whether you think you're stupid or not, if I were to take a large enough sample of the entire world population, you get those two words now, and if I were to measure intelligence in some way, this is what it would look like. All right, this shape, and you would be at the positive end, yeah? So a normal distribution is what you would expect normally, given no particular issues happening, no things skewing your... Remember I talked about skewed data before? Positive, negative skew. So if I were to just take things normal, all right, if I take everyone in the world and look at their maths test result, I would get a shape like this. Okay? So yeah, it's kind of like, this is what I would expect to happen given all things are normal. And you can do that with everything, you know. So not just maths test, you talk about, you know, people's heights and blah, you know, you've got some really short, some really high, but the majority sort of in the middle area. So normal distribution is what you would expect given nothing abnormal. So if I were to measure you as a small sample in here, right, then you as your own little tiny population, I might also expect a curve like this. Now, in some way, this can explain to you how your exam results are affected. Because how easy do you think it is to write an exam paper that's exactly the same difficulty as the previous year? We'd expect if someone's been paid for it, it shouldn't be that hard, right? But actually, it is quite difficult to get a different question and make it exactly the same difficulty level. All right? So what they tend to do is they write a paper that they hope is about the same. They then get you to sit it, like your IGCSEs or your e-assessments or whatever. And after everyone's done it, they then decide how much you need to get a certain grade. So I can't say to you, this exam coming up, you need to get 63% to have a 6. I can't do it. I can say roughly anywhere, in the past it's been anywhere between 59 and 67%. All right? And the reason for that is they want a certain number of 7s. They want a certain number of 6s and so on. All right? They don't want lots of 7s because that means their exams are too easy. So what they do is they mark them all, they work out all their results, and what do you think the distribution would look like? Like that, yeah? You'd get lots of mediocre scores, not very many really high ones, not very many really low ones. And what they do is this line here represents the mean. So they work out the mean score. That's where the majority of people will be. And then they start working around it and go, right, what do we want? So let's say we put that as a level 4. What do we want a 5 to be? What do we want a 6 to be? And how many people do we want to get a 5, a 6, and so on? All right. Does that make sense? Now, if this is why some years, you won't have seen this, but it's much more noticeable in the IGCSE course. Some years, the exam papers, the students will come out and go, wow, that was really hard. That was ridiculous. That was much harder than anything else you've ever given us, like past paper stuff. And then some years they'll come out and go, that was super easy. Now, the trouble with that is, if it was super easy, what do you think they're going to do? What has happened? Everything will have shifted up. Everyone may have found it super easy. So you need to do better to get the same grade than a harder paper. So if you come out of an exam like e-assessment or whatever and go, my God, that was harder than anything we've practiced before, don't panic so much, because you might, if everyone found it super difficult, the grade boundaries will be pushed back. They'll drop it.
So what if everyone only gets like 1 or 2 wrong? You can't give them like a 4.
Well, that's where you'd have to write a paper to make sure that doesn't happen. So that's why you need to also be aware that when I'm writing a test, I don't want you all to get super 100% or whatever. No, I want those of you that are better than the rest to be able to show that, yeah, and to extend you and push you, right? So you bear that in mind when you're taking tests. Tests will be written such that there is a range of, as a teacher, if I look at a test and you all get 100%, am I happy? No. No, I've written a test that's far too easy. Right? I haven't tested you at all. If I get a test where you've got a 3 for the one that I expected because they didn't do the homework, some 4s, some 5s, some 6s and a 7, I'm happy. I've got a nice full range of ability there and it's good. Does that make sense how things are done now? So with our normal distribution, there is something to be aware of then, which is these numbers are, you'll notice in the book, these numbers represent, okay, -1 standard deviation. So that's 1 standard deviation below the mean. And this line is 1 standard deviation above the mean. So whatever the standard deviation turns out to be, you know how to calculate it now. All right, so we can put a line kind of up to our curve. All right, and we have a range between 1 standard deviation above the mean and 1 standard deviation below the mean. So do you remember we did one yesterday where if I put numbers on these instead of just the ones and things. All right. Do you remember when we did an example yesterday where the mean was 5? What was 1 standard deviation? It was 2.2. So this number here would be 5 plus 2.2, which would be 7.2. This would be 5 plus 2 lots of 2.2, 9.4. And this would be, you know, so it would be another 11.6. Okay? And then going down, this would be 2.8. All right? This would be 0.6. And this would be
1.6.
negative 1.6. Yeah? Now, when it was test results, the only one that doesn't work here is this 1.6, yeah? Negative. But that's what it would be. So what do we expect then? So if things were as they should be in a normal situation, you'll see in your book that between the standard deviation lines, all right, we would expect there to be, and I don't remember these, but roughly 68% of the data should fall within one standard deviation above and below. Does that make sense? So if I added up everyone's scores and I looked at it, if I worked out the standard deviation, so I am expecting 68% to be between 7.2 and 2.8. All right? Make sense? Okay. Then the next one, so I've got then even further away from the mean. All right? This is within 2 standard deviations. You can see that I would expect 95% of my data should fall within 2 standard deviations. All right? So that's most of my data should not be any further than 0.6 and 9.4. Got that? There will be a little bit, right? But then we would expect within the... Sorry, I've kind of done it differently than the book.
95%.
That's 95%, yeah. Shall I rewrite it? So I'm going to, it's 95% is within the 2 standard deviations. So standard deviation. Okay. And then within 3 standard deviations, pardon? Not quite, actually. We always take into consideration that there might be some outliers. Okay. So within the 3 standard deviations, sorry for my lineup, it's not the same as in the book, I would expect 99.7%. So almost all of it. That might be the odd one mark, you know, one person. So out of 100 records, one, you know, I would less than 1 would be outside of that. All right, so pretty much all of our data, if things are normal, as they should be, there's nothing affecting it in any way, no outside interference. So for instance, you guys would not necessarily be normally distributed because the thing that's affecting you is the fact that you are in a private school, you know, parents have plenty of money to support you and give you what you need and blah, 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 you know, all these things, you know. You might think, oh, but that's not true. But if I compared you to people living in, you know, favelas in Brazil and things like that, you are very much kind of in that privilege. So when I'm talking about comparing everyone, that's what I mean. I'm kind of talking about everyone. Everyone that would possibly sit these exams. There are going to be people that are not affected by the same things yet. But you might say they're affected in the other extreme. They don't have access to the education, you know, so So given everything is normal around the world, we have some above, some below, we would expect almost all of you to fall within 3 standard deviations of the mean. All right? Whatever the mean is and whatever the standard deviations are, all right, that's what we would expect. Now, what does it mean if it's not? What if you only have 20% of your data within 1 standard deviation of the mean? Yep.
The mean is not effective?
Potentially, yeah. Could mean that, yeah. Also, what does it mean about the distribution? It's not
Even. Normal.
normal. It's not a normal distribution. If I've only got 20% of my data within 1 standard deviation, as Sienna said, it means it's too spread out. Okay, it's not, the mean is not particularly useful, and it's not a normal distribution. All right, so that's kind of it. That's introducing you to how standard deviation is used, and there's lots of calculations that can be done. Right, so let's move on. I would like you, all right, this is an interesting one to test your maths. Have a look at exploration 4 on page 88. I would like you to spend 10 minutes trying to do that. No more than 10 minutes, because it can be quite... Well, you'll see when you get to it. Okay. So it's some good maths for you, testing your algebraic ability. So it's exploration 4 on page 88. And this is where we're looking at finding standard deviation, okay, from summary statistics. So have a look at that exploration. Just, if you can't do it, it's not a problem. I'll go through it quickly with you, but have a go first. All right, so you are starting with a formula. Do you recognize the formula?
Yes.
What's it for? Standard deviation. Yeah, standard deviation. So it's the sum of x minus the mean squared divided by n. So it's the one where we've not got any repeated values as such. So it then says to you, expand the numerator. The numerator is?
The top half.
The top half. So we're going to expand x minus mu squared. Now, hopefully you would recognize that as, oh, I am now going to do this. 2 brackets the same. And it's the same thing as if I was asked to expand a quadratic like that. Okay, which I know you've done. So what we're going to do is we're going to expand this. So we get x times x is x squared minus mu times x minus mu times x plus mu squared, which then becomes x squared minus 2 mu x plus mu squared. You've all done that, yeah? Smiley face and eyebrows, foil, whatever you want to call it. All right. So then it tells us, let's write that underneath. So this is where they do give you some guidance, which is it still has to be written with this sigma notation. Okay, x squared minus 2 mu x plus squared, and that's still all over n. Right. Is that all right so far? It's nothing. It looks more complicated than you're used to, but there's no new maths there, right? I know you've all done foil or that kind of stuff. All right. Now we might be introducing you to something new, but it does kind of tell you how to do it. So it says distribute the sigma notation. So that's as simple as, okay, sigma. So if I've got to add up all these things already, so I can do them separately. So the sum of x squared minus, or it's got a plus, so let's do plus sigma of minus 2 mu x plus sigma mu squared. So I'm just filling in the boxes, and all of them over n. So I've just distributed, like expanding the brackets, the distributive property. You can do that with your sigma as well. Okay with that? Mm-hmm. It then tells you to distribute the n, which you should be all right with, because what's 2 plus 3 plus 7 all over 4? Well, you can do 2 divided by 4 plus 3 divided by 4 plus 7 divided by 4 and get the same answer, right? So when you add fractions, that's basically what you do, don't you? You add the numerators and keep the denominator the same. So that's all it's asking you to do again. So we've got sigma x squared over n plus sigma minus 2 mu x over n plus sigma mu squared over n. We've just separated it all out. Now, if you were doing this yourself, you might not ever go down this route. You know, someone else has done this maths for you. You're just following it through. All right. So I was having a chat with the M5s yesterday about what it means to be a genius. And we were saying a genius does things that haven't been done before. They think of new ways. A genius is not someone that can just do what everyone else has already done. So a genius is the person that can look at something and go, oh, I'm going to do something completely different. So a mathematical genius is someone that can find new maths. I'm not. All I can do is tell you what other people have done. I'm hoping at least one of you will eventually go on and find new maths. You know? And then I can claim being your teacher. Right, so then it says substitute. So we're told that mu, the mean, is the sum of x divided by the number of... That makes sense, right? And you're also told this one, I'm not going to try and explain to you. It does come up in the explanation above before, but I don't think they do it very well. So what they're saying is if you add up all the means squared and divide it by number, you get the mean squared. So it can be replaced, right? You're just going to have to take our word for that one at the moment, right? So let's just practice our algebra. So where can I replace a mu with this? So it says substitute them in. So I'm going to do this mu, I'm going to replace with this. Make sense? All right. And then I'm going to replace this whole thing with this one. All right. So I'm going to go with sum of x squared over n plus the sum of minus 2, but instead I'm going to replace it with this. I don't need another sum of, so I'm going to do x over n, but I've got another x and another n, so it becomes x squared over n squared. Okay? Okay with that? And finally, I'm going to have plus mu squared. All right? Yeah.
So the stuff that's highlighted in blue, you're replacing the -2 mean.
No, I'm just replacing
Just-
this mu
Oh, well, I did that wrong.
with all of this. So the -2 is still there, the x is still there. So
Wait, so that's
see-
what equals the mu. It's like saying like x equals
Wait, so
4,
you just
it
took
Yeah.
out the thing.
Yeah, it just looks like weird.
Why?
So what I did, if I kind of expand this bit, so I've got sum of, and the -2 there, so this mu is going to be replaced by this. So x over n, I don't need another sigma, I've got
Oh,
one.
it's replacing that, not the
Yeah, and
other
then
thing in blue.
This is times x, and then it's all still over n, all right? And if I've got a divide and then another divide, you just multiply the denominators, right? So that's when it becomes, the x times the x becomes the x squared, and the n divided by another n becomes divide by n squared. All right? So this mu has been replaced by the x over n. Okay.
All right.
You okay with that?
We don't get it.
What don't you get?
Well, I don't know. I just know
Why
that.
are there
Like,
two
I-
X's in that one? If there's
Do we have to
one
like
and one
memorize it?
above?
Like I did
No,
not
there's an
retain
X in-
anything. Like
Right.
There's an X in.
There's already an x up there, right? This mu has an x involved, so now there's two x's. Yeah?
Okay.
That's where the second x comes from.
Right.
Oh, that's
There's already one there.
I just like why like the entire thing. Like why can you like just replace it with those? Like where did they even come
I
from?
think you understand it, but it's just it looks complicated.
Yeah.
So it's like it
it's
makes
not.
no. see,
Why
it's
can
like-
I replace is a question, right? So that x is this x, okay? That's already there. There's one in there. Why can I replace? Well, I think Layla said it very clearly. If you can say x equals 4, well, anywhere you've got an x, you can write a 4 instead because they're equal. They're the same thing. So you have been told that mu has the same value as the sum of x divided by n. It's the same thing, right?
But that's
Because what does mu mean? The mean. And how do you find the mean? You add all the numbers and divide by the number. That's what that is, yeah? The sum of the numbers divided by the number of numbers. So instead of writing the symbol mu, you just write what you did.
Well,
That's all you
then
did.
why does it at the end when it says the mu squared? Why can't you just?
Because I've replaced all of that with what they told me I can replace it with.
Right.
Right? So this one here is replaced, you know?
So that's why in the second
Yeah, but like if you're trying to get rid of the mu.
But we're not there yet.
Oh.
Right? We're not there yet.
Oh.
So the next stage, right? Collecting like terms, we've done. All right? We've done our collecting like terms.
These are the exact same thing.
All right? What we're going to do is then they tell us, the next thing that they tell us is that we're allowed to replace mu with this again. All right? So the same thing. Now this time, so hopefully this won't confuse you too much, I'm going to deal with this one and I'm going to replace it with this. All right?
But it's square.
Well, okay. But do you remember we said whatever you replace. So the mu is the thing that I'm going to replace. So I'm going to put a bracket and I'm going to keep the squared, right? And I'm going to have the sum of x over n, like that. Okay? And I've still got, this time, this is something you'll just have to, if I've got -2 times it, I can actually put this outside the sigma. Right? So I've got -2 lots of the sigma x squared over n squared, plus I've done that one, and I've still got my sigma x squared over n, all still square rooted. Okay.
I just need a second for that. Is it?
So, just to be clear, so this mu, right? I've been told I can replace it. So that's what I've replaced it with. Okay? Sorry, I actually maybe make it clearer. I'm going to put the sum of back where it was, inside the square. So the whole thing is square. You okay with that?
So it's
And the only other thing that I've done, you need to try your best at this rather than just give up, because these are skills that you have to be developing. Okay? So the -2, because if I add up 2 lots of x squareds, it's the same thing as add up all the x squareds and have 2 lots of them. So I can put the -2 outside. Just, there's a reason for that. Okay? Right. I did say it's a tough thing. Okay? I can see some of you are definitely, all of you are definitely writing and trying, which is all I can hope for. Are you happy with that substitution? Yeah? Right.
Once you know how to do it, it doesn't seem too difficult. It's just like, it's pretty much just following the directions.
Yeah.
Once you know what to do,
Yeah.
you just follow.
So then the final thing, which is where we get to the formula that you'll need to use, is that we've got our sum of x squared over n. Now, this here, okay, just like you've done before, so 3 over 4 all squared is the same as, using your laws of indices, 3 squared over 4 squared. So this I'm going to change to -2 lots of sigma x over n all squared, yeah? That comes outside. Plus, I've still got my sigma x over n all squared there. Okay? So the only thing I've kind of done anything with at the moment is kind of just taken these squareds and put them outside the bracket.
is there supposed to be a plus in between the sigma x squared over n and the -2?
Here.
Or are
That's
they
-2.
together?
So if I add, so you'll notice that I always add, but the -2.
Because you put
So because the 2 came this side, I now have a subtraction instead. All right, now you'll notice, or hopefully you'll notice, that these 2 here, all right, these 2 are now like terms, right? They're both sum of x. But how many of them have I got here? -2 plus 1 of them. So it ends up being not 0,
Oh, wait.
-1. So I end up with, yeah, sum of x squared over n minus 1 lot of the sum of x over n squared. Okay. It's a long-winded process, but you'll see why we get there. So we've shown that our original standard deviation formula, which you all knew where it came from, yeah? You find the difference of all numbers. Well, what do we have here now? What are these 2 things?
Like terms.
They're not like terms now, because this is x squared over n and this is x squared over n squared. But what is the sum of x over n?
The mean.
The mean squared. Yeah, just the mean squared. And what is this? It's not the mean squared, but this is add up all the numbers that have been squared. So all we actually need to do our standard deviation now, using this formula, is square all the numbers and divide by them, and then subtract the mean of all the numbers squared. All right? So we kind of need less information, if you see what I mean. Okay? So these now are what we would say, these things are using the summary statistics. So we don't need now to work out every number from the mean, square it, blah, 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 add them all up. All we need to do is square the numbers, add them up and divide, and then subtract the mean squared. We only have to do that once. Does that make sense? How it's a bit quicker? Packed up quickly. Open your book just as a token gesture for me. Okay, so we're going to look at this, how we're going to use this next time. So, if you are keen on doing well in your maths, you might choose to review this exploration, review the video, and try to understand it a bit better if you found that hard.